In this video, I wanted to show you how to create scatter plots and do linear regression in Microsoft Excel. You can go ahead and start by opening the Excel practice file for this chapter's lecture notes, which should contain the same data that we worked on in this week's lecture videos, which would include Amanda's fictional quiz scores and her time spent studying. And so the chart in Excel should appear exactly as it did in the lecture notes, which it appears to be doing. So to start off with the scatter plot, one thing I wanted to mention is that if you just select all your data and go into insert, there's a little button that looks like a scatter plot just with a bunch of little points on it. That will create a scatter plot for you. But what I wanted to mention about how Excel works, it will automatically use the data on the left as your X variable or as the explanatory variable, and the one on the right as the Y or response variable. And in this case, we decided that it made more sense to have her time spent studying as the X variable. So what we just want to do is change where it is. So we can select it all and hit cut and paste. That will kind of, I guess we want to insert cut cells, not paste. And that will switch the order. That way, when we go to create our scatter plot, it will put this over here. It will have the proper axes because we wanted the time she spent studying on the x-axis and her scores on the y-axis. Now we can, this would be totally fine to leave it as is, but we could customize our x and y axes, and I might as well, let's go ahead and look at how we do that. So if you just click on the axes like this and hit right click format axis, this will give you a set of options which, sorry, it's kind of small, but you can choose like what's minimum, what's maximum. And like in Amanda's case, her worst score was 54. So we could just set the min to say be 50 and the max to be 100, because most likely you can't get higher than 100 unless extra credit is allowable. And that would give us axes. Actually, in this case, it'd be the same as the one that we used on our graph. And so, you know, it would just be, we can compare to the graph that we created by hand and see how we did if we change them to the same parameters. You can also edit the title by just clicking it. And I'll label my chart here just so I know what is being shown. So I'll go ahead and say it's the quiz score based on time spent studying. We could even label axes and so forth, but let's not do too many bells and whistles, just get the basics. So there's our scatter plot. The next few things we did is we calculated the x mean, the y mean, the standard deviation for both x and y. And actually some of these we had done the week before. But remember that you can do these in Excel by using the equal average command and equal stdev.s command for calculating those. But in Excel, what's actually very nice is it does all of the least squares regression. It can do it very easily. You don't have to do it all manually, step by step. And so how to do the regression, basically to skip, we calculated the correlation by hand. We calculated the slope of the regression line and the intercept of the regression line. We did it all manually. But in Excel, it's very easy. How you can create the regression line is if you just click on your data points. There's more than one way to do this, but notice how it selects all the data points. If I now right click, there should be an option to add trend line. And basically what this will do is it will do all the math in calculating the least squares regression line for us. And also notice that there's an option to format the trend line. If this does not appear for you, you can always right click the trend line and choose the format trend line option. And there's actually options of changing these from linear to other types of best fit, which might be relevant in other situations. But for now, we're just sticking with linear regression. And the options at the bottom say display equation on chart and display R squared value on chart. And those can be, basically this is how we can get those values that we wanted, like the value of the correlation, and then the equation of the trend line. So I'll go ahead and put a little formatting on this, but you can drag it around, move it around, change the color, whatever you'd like, kind of to spruce it up. But anyways, there we have it. There is our equation for trend line. So let's check it out. Let's see how we did in our when we did it. So for what we got is we got that our correlation was about 0.929. Now, in Excel, it will display the r squared, but not the r value. So that's just something to note. Now, if we wanted to figure out what is r, we could always do equal SQRT is the square root. And then we could just calculate the approximated square root of the r square value that is on our chart. And it says it's about 0.929. So it looks like we did not mess up when we calculated the correlation by hand. And as we're looking at our least squares regression line, or, again, as Excel calls it, a trend line, we had a slope of 9.34 and a y-intercept of about 59, and that appears to be the same, 9.34, 58.96. Yeah, and if you round those, you'd get pretty much the same thing that we got. Again, it's more accurate because we did quite a bit of rounding as we were doing those calculations. Another thing is if you wanted to do the residuals in Excel, basically I'll go ahead and show you how you could do this as well. We calculated the residuals for the first point and the sixth point, but basically first you need to have the equation of your least squares regression line, because that's going to tell us what the predicted value would be based on the best fit. So basically, let's go ahead and I can make a column here, which is my y hat, my predicted value based on my line. And basically what it would do is it would determine where the points would be on the line if she spent that much time studying. And so basically for each data point, I want to figure out what the predicted y value would be. Since we know the actual quiz score in each data point, but if we use the line, we could predict it. And that would just be by taking 9.3448, multiplying by how long she spent studying, which is x, and then add that to our intercept, 58.966. And this would give us our y hat value, or the projected quiz score based on her time spent studying. And if we use the little button on the bottom right with the make sure that Excel changes to the little plus icon, we can drag the formula down, and it should work in calculating the projected quiz score for each. And remember that the residual is the difference between the actual quiz score and the predicted quiz score. Basically, what is the actual y value minus y hat? And that by first calculating y hat, I could now find, well, what is y minus y hat? And seeing, well, that's her actual quiz score that she actually got in real life, or fake life, because it made up these numbers. But it would be, she actually got 100, and our line projected her to be 91.6. And remember, the idea behind this is that, we have real data points. She got 100 when she spent 3.5 hours studying. But if we, projected on the line, she would have done a little worse based on the projection. And the residual is just that difference between actual and projected. And that this is how we could calculate all of those in Excel. And again, I could copy those formulas down to figure out what would be the difference in each score and projected. And I could then use these to create a residual plot such as this, and so on. But, from the first data point, it says her residual is 8.3. Yeah, in our chart, it's a little more accurate because Excel uses many more decimals than we did. With the sixth data point, we got about a -2 residual. Makes sense. So it looks like a lot of the math that we did, everything seems to be working, and Excel is a nice way to quickly check these sorts of things. And yeah, that'll wrap up this video.